Hello, everyone. I am Professor Fuad. I would like or to do kind of orientation for how to conduct the physics lab online. It's actually all the physics experiments so far, we have them kind of simulation. It's the same way you conduct them in the lab, same way. Sometimes it may be better, and they'll show you now just very simple samples. So, okay, let us see now, like usually in the physics lab, we start with measurements and errors. So if we would like to measure something, say circumference of a circle and its diameter, and how do they are related to each other? Absolutely everyone take physics, you know the circumference equal diameter times pi, 3.14 or 22 over 7. This is how is the relation between the circumference and diameter. Circumference divided by diameter equal pi, or pi times diameter equal circumference. So let us see now the first lab orientation. So this is the objective of this video, how I can conduct physics lab online or virtually. How can I do my lab, my physics lab virtually? This is the objective of this video, by the way. So let me start with you for something. Say now, I will share with you this slide. So right now I have different shapes as you see in the screen. I wanted to measure the diameter and I wanted to measure the circumference. But definitely in physics, we will measure everything at least 3 times. Circumference 3 times, diameter 3 times. You maybe tell me that, oh, I get the same number. No problem, that's fine. But you have to measure it 3 times and do your best to get it as accurate as you can. So say now, I will measure first, I will start to measure the diameter. So I will take the ruler and I will start with the largest one. And by the way, the ruler, if you see it is jumping. But if you hit control and use the arrow on the screen, you can move it more accurate. So I see, by the way, now if I am in the middle, I see it look like my diameter is 9.9. So let me switch with you. So this is the diameter. So I will record now here on with my other camera that I have the diameter is D equal 9.9. But this is D1, by the way. I will take D2, then I will take D3. So let me go back and measure diameter number 2 and the diameter number 3. So in the same circle, by the way, for each one of those, I do not move to the second large one or medium one or smallest one. I'm still in the biggest one. So maybe one can tell me, okay, but you know what, if you maybe move a little bit, okay, control, I think I shifted. Yes, this one. He told me, you know what, I see it is 9 centimeter, 9.94. And another one told me, I think I can make sure that I'm accurate. So control, that's 9.89, say. So right now I get 3 measurements. You know, maybe student 1 get this one, student 2 get this one, student 3 gets this one. Absolutely everyone, we respect the reading that you get it. But what is my final reading? It is the average of this reading. So how can I get the average? I have to switch to Excel file. So let me share this with you, share. Then this is the Excel file, and this is how to do it. So first reading is 9.9, second reading is 9.94, third reading is 9.89. Then enter, this will be here equal, just punch equal, average, and take the 3 readings, then close and enter. This is my average. So my diameter for the first circle that I started with the largest one, largest, large, medium, small. So the largest one, the largest equal 9.91. So this is my measured value, by the way. Okay, so I will go back. This is just type of how to do, by the way, measurements. So this is my screen. This is my circle. And I am measured now the diameter. I will move the ruler out. Then I will I need to measure the circumference. So to measure the circumference, by the way, there is another tool here. And by the way, how to measure everything online, this will be given to you from your lab instructor, whatever. So I wanted to measure this circumference. So with this tool, I wanted to make sure that these small lines, the scale, just to touch the circumference from outside. So I see now it's not focused good. Let us work in it. How about this? Yeah, it seemed to be good now. I think I just wanted to move the whole thing here. Yes, but I would like to focus by control arrow. Yes, it's let me a little bit increase it. It's just one thing. Okay, control. So right now, I see it's kind of focus, you know. So let me move it to the right a little bit. Yes. And so then right click on the scale. Sorry, I need the circle, right click. So size and position. Did you see this is 312? This is the scale height, which is the circumference of this circle. So the circumference here and this one is 312, but it's millimeters, by the way. This scale is in millimeters. So if you pay attention with me, I will go back for this camera for the other ones that we calculated from, and I share this with you. So circumference C is 31 millimeters, which is 31.1 centimeters, and circumference in the circle equal pi times diameter. So 31.1 equal pi 3.14 times diameter in centimeter. So diameter equal 31.1 divided by 3.14. So this is my calculator. So it is 31.1 divided 3.14. So that's 9.90. This is 9.9044, which is 9.9 because this is 0, we cancel it centimeter. So right now I get two readings. This one I measured. This is one I will call it measured value. This one accepted value. Accepted value. You have two values. So error, percentage, error equal accepted minus measured divided by accepted. Absolute value anyway, because error, if it's up or down, it should be count error, even if you get less or higher. Like if you get the acceleration to the gravity less than Newton, it does not mean that you are more accurate than Newton, but it's error. So whatever the value, so this will be 9.9 minus 9.91 divided by 9.9 times 100. So let us calculate this. So it's 9.9 minus 9.91 divided by 9.9 times 100. This is actually 0.1% error. That's good. As far as you get your error within acceptable, like within tolerated plus minus 5%, If you see me here, this is negative, but we don't take it negative. We take it positive because this is a scalar value. So this is, by the way, just one value. So how can you do this in your lab? You have to do the whole circles, like you have 4 of them. You have to do the whole 4 of them. You have to measure every one, diameter 3 times, circumference 3 times. Then you will do table. This is diameter. This is circumference, centimeter. So like diameter 1, circumference 1, diameter 2, circumference 2, diameter 3, circumference 3, diameter 4, circumference 4. And by the way, this is, you will take the average of each one of those. Then you will go on Excel sheet, you will plot like 0, 0 anyway, you have 0, 0, then D1, D2, D3, D4, and this is C1, C2, C3, and you will get a slope. Your slope here, the slope of this line will be equal pi. Supposed to get it pi. You're supposed to get 3.14 your slope, but if you get it like closer to 3.14, that's fine. This is one type of lab, by the way. So what is the other types of lab? Because this is simulation and it's very easy. Say now we wanted to work simple pendulum. Simple pendulum means what, by the way? Simple pendulum means you have thread hanging and you have mass here. In the lab, we need to get the length, and we need to measure, say, the periodic time. T equal 2 pi radical of L over G. So how can I conduct this lab? This is the way how to conduct this lab. Please see with me this simulation. I got it ready, by the way, before the lab, before I start to, so if you see it here with me, this is the pendulum, simple pendulum lab simulation. Okay, so yes, we need this. Nice. So this is the lab, by the way. So right now, say now I wanted to measure the length. I wanted to measure. You can use this ruler, by the way, to get the length. If you pay attention with me here, put the 0 up, how many centimeters you have. You have like closer to 70, maybe 70, yes, because you take it from the center of mass. But if you pay attention with me here, it's given for you easy. Top right, this is 0.7 meter. So instead of use the ruler, that's nice. You have it here digital, even better. Say now I want to make it 60. You see this? So I want to go down, 60. I wanted to make it 50. This is 50. Make sense? Then I want to change the mass of the bob. It's 1 kilogram. I can make it up to 1.5 kilogram. I can make it 0.5 kilogram, whatever you like. That's easy, you know? So this is the way. If I would like to count the time, periodic time for one oscillation. So did you see this is stopwatch? Click it. This is a stopwatch. Then you can see the trace, period trace. So you can see how it look like. I prefer to make the angle 20 at the beginning, by the way, or maybe 15, better also. Then now it started to do. I would like to measure the time when we have the length, say now 70. So what is the periodic time with length 70? Okay, we will start the stopwatch while we're here, then we go forward, backward. This is 1 oscillation, 2 oscillation, 3 oscillation, and so on. So let me count. I will start with this here, and I will count. 1, 2, 3, 4, 5, stop. This is the periodic time for 5 oscillation, but definitely we recommend you to take it up till 10. Then if you divide this 8.12 by 5, you will get the period for 1 oscillation only, and it's so on. You will take table between length and periodic time. You will increase the length to make it like, say, 75, 80, 85, 90, 95, 100, and so on. And every single time, you have to get the periodic time. Then later on, we will make the length constant. Then we change the mass of the bob. Anyway, the simulation in front of you now, you can do a lot of more than 3 experiments from it, by the way. So if I show this for you, can we see the energy, the track of the energy? If I see now energy, if you pay attention with me, while this one is here, I would like to stop it, to pause it. While it is here, by the way, it is somehow have potential energy and the kinetic energy. When it is here, like in the middle, so let me make it slow motion because I wanted to make it slow. So this is now, we consider it almost zero potential because this is a bottom, minimum point, no height. We consider it relatively, this is a zero height. So the potential energy, if you pay attention here, potential energy is almost zero, but it should be maximum kinetic energy. So if we go to the normal and we would like to work it out. So let us work it out. Now, if you see here, this is maximum potential, no kinetic. If you go here, this is zero because I'm stopped, but let me isolate it. So did you see now the potential and the kinetic, how did they are? I will pose it like randomly. This is maximum potential because it's almost highest point. And at this point, by the way, it will switch back. So it will stop momentarily, then go back. So how can I see the stop? How can I see the velocity and the acceleration? Did you see this with me? That's nice. So velocity, the green, and the acceleration, yellow. So can we see these both? Yes. Can we work it out now to see how much of the velocity? See now, when it's go down, maximum V. But when it hit the vertical, almost zero V in this direction because the velocity direction will be backward. So this is, by the way, the acceleration arrow. When it's go down, the acceleration, like it should be in the same direction. So if you pay attention with me here, when they are the same direction, at the center, the acceleration will be almost zero because the speed at this moment, the maximum speed, but it should be stop momentarily, kind of constant at the same moment. They'll start to decrease. Decrease means the acceleration backward. Acceleration will go backward. So this is acceleration. So this is, by the way how to do it. I'm just to give you introduction, by the way, but this is how to see it or how to measure something online, how to conduct your lab virtually. You can, as you see here, you can get the ruler, you can get the stopwatch, you can trace and everything here, which should be kind of nice usually. So this is how to conduct your lab virtually, my friends, and every single experiment we have certain simulation with the tools that we need to perform the lab. I hope you will enjoy this lab and thank you for listening and enjoy your time and stay safe. Thank you so much.